Today I will be teaching you the application of logs. So to begin with, we have two different scenarios. We have growth and decay and appreciation and depreciation. Today I will begin with growth and decay. So the formula for this scenario is y is equal to a bracket b bracket to the power of k divided by t. In this scenario, y is our final amount. And then a is our initial amount. B is our fold. And K is our time to get to the final. And T is our time per fold. So to begin with, I have an example. I have a bacteria population triples every 7 hours. At this rate, how long will it take for the population to quadruple? So we're going to write down our initial formula, which is y is equal to a bracket b k divided by t. So for y, our final amount is going to equal 4. So we have 4 is equal to our initial amount is a, and a is going to be 1. Our fold is b, and b is going to equal 3 as it triples every 7 hours. So 3. And k is unknown because we don't know how long it's going to take to get quadruple the population. And t is going to be 7 as it takes 7 hours to triple every time. So from here we can solve it. We disregard the 1 as anything times 1 is the same. So we have 4 is equal to 3 k divided by t. We can change that from exponential form to logarithmic form by adding a log and doing that. So log 3, 4 is equal to, t is equal to 7, Log 3, 4 is equal to k divided by 7. We can multiply 7 on both sides so that the 7's cancel out. So we have 7 times log 3, 4 is equal to k. And once we plug that into our calculators, we get our answer of k is equal to 8.8 hours. And that's our answer. Our second formula is for appreciation and depreciation. And the formula goes a is equal to p bracket 1 plus or minus r over n to the power of nt. So in this scenario, a is our final amount. P is our initial amount. 1 remains the same. The plus and the minus depends on if it's appreciation or depreciation. R is our rate in which it's compounded at. And this must be left in a decimal as rate is given in a percentage. N is how many times it's compounded per year. N appears twice in our equation. And T is our time. So for this one, we have the example of how long will it take to earn $200 of an investment with the initial investment of $800 at this interest rate of 12%, compounded semi-annually. So we're going to write down our formula for this one, which is A is equal to P bracket 1 plus minus r over n to the power of nt. A is our final amount, and that's going to be $1,000 because we're looking to earn $200 plus the $800 we already have. So A is equal to 1,000. P is equal to our initial amount, and our initial amount was 800. One is our constant, so we're going to remain that. And this is going to be a addition problem because it is appreciating and not depreciating. If it was depreciating, it'd be a subtraction. Our rate is 12%, so our rate is going to be 0.12. And it's compounded semi-annually. So that's twice a year. And we don't know what T is yet. So to begin with, we're going to start by dividing both sides by 800. $1,000 divided by 800 is 1.25. And then that's equal to, so these cancel out. 1 plus the rate over 2, all to the power of 2t. So when we figure this out, we have 1.25 is equal to 1 plus 0.06, as 12 divided by 2 is 6, to the power of 2t. Then we have 1.25 is equal to 1.06 to the power of 2t. Now we can change that into a logarithmic form by adding log. So log 1.06, 1.25 is equal to 2t. And then to isolate t, we divide 2 on both sides. You plug that into your calculator, and you get t is equal to 1.9 years.